So now this video discusses about what they call as the trigonometric substitution method of integration. So what is a trigonometric substitution method of integration? According to the principles behind this method of integration, the essence behind is that we'll be given the expression that is to be integrated, but we should have to express the expression or the integrand to be in a trigonometric function, and that we can easily integrate and take it back to the originals, and we can take it back to the original function as that of the original state in terms of the variable. That's what we call as the trigonometric substitution of integration. We'll be given the expression that is to be integrated, but now we should have to express it to be in a trigonometric function, or should be in a trigonometric form, and that we can easily integrate. And now from that point, we should take it back to the original variable of the actual expression. That's the principles behind it we should have to understand. But before we proceed further with the discussions, what you need to understand before you go for this lesson is that you need to understand about what we call as the Pythagoras theorem. I understand you know what is Pythagoras theorem. You need to understand about what we call as that of the trigonometric ratios, the likes of, let's say, a sine, cosine, sec, should be secant, cosecant, sort of. That's 6 basic trigonometric functions we should have that on. And I should also have to understand about the trigonometric identities, the likes of having the tan is the same as having it as the sine over cos, having the secant is the same as 1 over that of the cos, and what have you should have to understand. Of course, we'll be applying them in the video, but make sure that before you go for this, you have gone through all those things. And apart from that, you should also have to understand about the concept of the Pythagorean trigonometric identities. But let me just have to highlight some of the things involved in the lessons before we go further with this. If we have, let's say, this is Larangue triangle, let me just have to adapt this. Let's say this is a typical Larangue triangle, and this is the triangle A, B, C. And now, let's say that is the case. So according to the Pythagoras theorem, it is states that the side AB square and plus the side BC square is the same as AC square, and this is what we call as the Pythagoras theorem, and this is known as the hypotenuse. So in all cases, the square summation, in all cases, the summation of the square of the two sides of the triangle, of the Larangue triangle, is the same as the square of the hypotenuse. So this is what we call as the Pythagoras theorem. You just have to keep. And what are the trigonometric actually functions? We have the likes of a sine. We should have to understand about the sine theta. And let's say, let me just have to give you the big part of it. I understand this is a typical, it should be a review for this case, but you just have to do it a little bit more for the sake of some of you who may not agree have the information about this. But in case you want to have the more detailed structure about the trigonometry, just have to search my videos on a YouTube channel or whichever the internet source that you can have. GB Analytical School of Science, the trigonometric functions. You come across the list of several videos I made about trigonometry and sort of. Let's say this is a side A, and this is the side B, and this is the side C. And say this is, let's say, an angle theta given as that. So a sine theta corresponds to have it as should be opposite divided by the hypotenuse. So what is the opposite side corresponding to the angle theta? We have it as A, therefore have it as A over C. And on the case of the cos theta, what it does is that is the same as the adjacent of hypotenuse. That is given as B over should be C. And by the way, let me have this one as this is the opposite and this is hypotenuse, and this is the adjacent, and this is hypotenuse. And by the way, based on the angle theta that we have, it is there. And we have what equates as the tan theta. Tan theta, that corresponds to have it as the opposite adjacent, which is A of B. We should have that. Of course, tan theta or tan is the same as having it as also being the same as the sin theta of cos theta. So which is the same as, what is the sin theta? We have it as A over C divided by, what is the sin theta? We have it as, A over B. Which is the same as having it as A over C and times B over, should be somewhere about, let's say, A. And this will cancel. That is the same as, B over C. Should be B over C rather. Should be, what is that? Is it B over C? Let me have it on the same way. Let me have it again here. So what I'm saying is that what is a sin theta? Sin theta corresponds to have it as, should be opposite hypotenuse. That is given as, should be A over C, of course. And what is the cos theta? That's divided by, what is cos theta? Cos theta corresponds to have it as the, should be adjacent hypotenuse. So what is the adjacent? We have it as B. And what is the hypotenuse? We have it as C. Therefore, or have it as, should be B over C. Of course, that is the same as having it as A over C times C over B. And the C's will have to cancel, or have it as A over B. So which is the same as that. And now, apart from that one, we also have the other case. That's what equates as, should be cot theta. A cot theta corresponds to have it as 1 over tan theta. Which is the same as 1 divided by, what is tan theta? Should be 1 divided by, what is it, tan theta? That corresponds to have it as sin theta over cos theta, which is the same as having it as cos theta divided by the sin theta. So what is that? Then we have to substitute. What is cos theta? Cos theta corresponds to have it as B over C, and that's divided by, what is sin theta? That is A over C. Now this is the same as having it as B over C times C over A. Thus we should have it as that. So a cot theta corresponds to have it as B over A. Really, it is an inverse of a tan theta. As you can see, A over B, now we have it as B over A. So it's just an inverse. So for that case, what it does is that the cot theta is given as B over A, which is the same as that of 1 over tan theta, which is the same as the cos theta of sin theta. That is in case you may need to have just a little part of the information about the trigonometric functions. And apart from that, I also have what equates as the sec theta. So a sec theta corresponds to have it as 1 over cos theta, but which is the same as 1 divided by, what is cos theta? That is B over C. And therefore we can have it as C over B. That is the value of the sec theta we should have. And we also have what equates as the cosecant theta. Cosecant corresponds to have it as 1 over sin theta. So what is 1 over sin theta? That is 1 divided by, what is sin theta? That is A over C, which is the same as C over A. We should have this. So that's the basic idea behind the trigonometric functions. And apart from this, we should also have to understand about what equates as the Pythagorean trigonometric identities. So what is that? These are the identities that will base the Pythagoras theorem. And basically it starts with Let me just have to create some spaces here before I take it far. So on the case of the Pythagorean trigonometric identities, the point of interest is that if we have a sine square theta plus a cos square theta, this is the same as 1. So this is what they call as the Pythagorean trigonometric identity, and keep it as should be something important. Now if we divide everything by sine theta, should be sine square theta, we'll have another Pythagorean trigonometric identity that we should have. That is, we have it as 1 and plus cos square theta over sine square theta. That corresponds to have it as cot square theta, and which is the same as 1 over sine square theta, and that is cosec square theta. We should also have to keep this in mind. And apart from that, we should also have to understand that if we now divide both sides by cos square theta, what we'll have, it will be something different. We'll have it as sine square theta over cos square theta plus 1, which is equal to 1 over cos square theta. That is the same as, tan square theta plus 1, which is equal to somewhere about sec square theta. We should have this. So those are known as the Pythagorean trigonometric identities that you need to understand. So that's how we should have it. Now another important concept you need to understand is about what they call as the U substitution of integration. So what is U substitution of integration is all about? Let's say if we have the integral of, let's say, x times the square root of x squared plus 2 dx. The integral of this expression is done using what they call as the U substitution, where we should have to express let u being given as x squared plus 2, and now the derivative of u is given as 2x and times dx, since the derivative of 2 is given as l. Now we should have to make dx as the substitute to have it as dx is equal to du over 2x, and now we should have to substitute. That will be given as the integral of x square root of u times what is dx, that is du over 2x. Thus we should have to cancel that one, and therefore have it as the integral of square root of u, and thus we should have half outside. And now that is the same as having it as half integral of u to the power half, thus du. Now what is the integral of this expression? Now what it tells is that we should have it as something about, we should have it as half u to the power half plus 1 divided by half plus 1 and plus c. That's the integral. And now from that point, what it does is that we should have it as, should be somewhere about half u to the power 3 over 2 and divided by 3 over 2 and plus c. And from there we should have to take it back and substitute for u. That is the same as having it as the half. And what is u? That is x squared plus 1 to the power that of 3 over 2. That should be 3 over 2 and divided by 3 over 2 plus c. And thus now we can have it as this. Thus now we can have a something about this. Let's say if half now will be given as, should be the half times 2 over 3 and x squared plus 1 to the power 3 over 2 plus c. And these two cancel, have it as 1 over 3 square root of that of should be square root of x squared plus 1 and to the power 3 and plus c. So this is how we should have to understand about that one. And also let's try to do it more on the U substitution case. Now let's say if we have the integral of, let's say, 2x of let's say square root of x squared minus, should be 6x. So how do you think we should have the integral for this case? Principle remains the same, in the sense that we should have the U substitution. That would be given as u is equal to x squared minus x. And now the du have to be given as 2x dx. And what is dx? Dx corresponds to have it as du over 2x. And now we should have something about, the integral of 2x over, that is u square root of u, and times du over 2x. And now this x and this x will cancel, and also this 2 and this 2 cancel. What we'll have is the integral of 1 over square root of u du. That is the same as the integral of u to the power negative half and du. And what will be the integral? Have it as u to the power negative half plus 1 divided by negative half and plus half, actually a plus 1 and plus c. What we'll have is something about, let's say we'll have it as u to the power should be half divided by half and plus c. That is the same as having it as, what is the u? We have it as x squared minus x to the power half and divided by half and plus c. And that corresponds to have it as somewhere about, it should be, thus we have it as 2 times the square of, x squared minus x and plus c. That's the good part of it. And of course, sometimes you can also use what they call it as the changing of the variables of u substitution as well. And that is, let's say if we have the integral of, let's say x should be x squared and times, let's say x minus should be 2. So how do you think we should have the integral of this expression? Principle remains the same. This is the same as u is equal to x minus 2, and what is the du? We have it as, dx, and therefore dx is the same as du. We should have to substitute it back. That is the integral of x squared, square root of u, and what is dx? That is du. Still more, we have x as the variable that has not been expressed in terms of u, and therefore we should have to express x squared in terms of u, in the sense that we should have to express x as the subject. There we'll have it as, u is equal to x minus 2. That is the same as x is equal to u plus 2. Therefore, we should have to substitute x for u plus 2. And that corresponds to have, something about the integral of u plus 2 to the power 2 and times the square root of u du. And I would have to expand it there. That will be given as the integral of u square plus that of 4u plus 4 and times the square root of u du. And I would have to distribute the square root of u. That is the same as, the integral of, now we should have it as, u to the power 2 the power 2 plus half. That is according to the laws of indices. Let me just have to, squeeze it more. I just have to have some spaces here, and thus you should have the clear picture on what is happening. Now the point of interest is that we should have to distribute square root of u. That is given as square root of u corresponds to have it as u to the power half. And now u to the power half times u to the power 2, that is the same as, the integral of u to the power 2 plus half, of course, and plus 4 times u to the power 1 plus half, and the plus that of 4 to the power half, and we should have du here. Understand, what is u substitution, that involves the changing of the variables. It's not something new that you should be surprised about. We should have to add actually 2 plus half. What is that? 2 over 1 plus half. Using the butterfly method of adding, fraction, that is the same as 2 times 2, that is 4, and plus 1 over 2, that is 5 over 2. And thus we should have it as the integral of u to the power 5 over 2 and plus 4 to the power 3 over 2 plus u to the power half and we should have the 2. And now from there we should have to now integrate. We are on the verge where we can be able to integrate the expression, in the sense that we should have it as something about u to the power 5 over 2 plus 1, 5 over 2 plus 1 and plus 4, u to the power 3 over 2 plus 1 over 3 over 2 plus 1 and plus, somewhere about that should be, and now that's we should have it as should be u to the power 1 over 2 plus 1 divided by half plus 1 and plus c. You should have it as that. And what if, let's say, in this case we should have to add the fractions, we should have to add these, then we should have to substitute back for u, and that's x minus 2. So that's how we should have to integrate that expression, and that is. So this was a typical reminder that we should have to understand about, far as u substitution of integration is concerned, and in that way. So we may have some cases that you should also have to understand. Sometimes you can also have the cases that goes like this. We can have some actually integrand or some expressions that are to be integrated, but having a ladigos, in the sense that you can have it as, let's say, square root of, let's say, x squared minus a squared, let's say something like that. Let's say we have a case like, let's say, x squared plus a squared can be that, or else let me say we can have also the case being given as, let's say, should be a squared minus x squared. Sometimes these cases may not be easily integrated using u substitution. Of course, some cases the u substitution may be possible, but in some cases it may not be possible. Thereby, we should have to use the principles of what they call as the trigonometric substitution. And basically, these expressions are the ones in which these radicals are the denominators. So a trigonometric substitution is basically used whenever we have these forms of expressions as the numerator as the denominators, but u substitution, but the ones in which u substitution cannot be actually applied. So we use what we call as the trigonometric substitution. So on the case of the trigonometric substitution, that's where now we are transforming the expressions to be in form of the a trigonometric function, and is such that you can easily work it out, then take it back to that of take it back to the original variable of the function. So that's the basic idea behind the trigonometric substitution. Just have to appreciate the view of some of the cases to have to understand. Imagine we have, let's say we have the cases like, let's say, the integral of, let's say, dx over, let's say, the square root of x squared minus, let's say, 4. This kind of cases, you may find it hard to integrate using the u substitution. So in this case, we're going to use what we call as the trigonometric substitution. Thus, we'll be able to integrate it. Of course, it was just part of, you should have to appreciate. Or else think about this. Let's say the integral of, let's say, 2x squared and divide by, let's say, square root of 9 minus x squared. You can see also this one want to be easily integrated using u substitution. Therefore, we should have to use what we call as the trigonometric substitution, because u substitution will not be possible, or else it will give us a lot of troubles for us to integrate it. So therefore, the easiest way is to use what we call as the u substitution. So in such cases, whenever we have in such cases, whenever we have the following cases, let's say the case of square root of, let's say, a squared plus x squared as the denominator. Where your substitution may not work, we should think of, what equates as the trigonometric substitution. And we should also have, let's say if we have x squared minus a squared, we should also have to think of the trigonometric substitution. And if we have, let's say, a case like this, and that is, let's say, a squared minus x squared, you should also have to think of the trigonometric substitution. But now the question says, how should we have to, turn out from this actually algebraic expression to trigonometric expression? How do you think we should have that understand? Now, if we have a case like this, x corresponds to the variable and this one corresponds to the constant. If we have the summation of the constant, and by the way, I'm saying this is the constant and this is the variable. And now, if we have the summation of the constant as well as the variable, then the key that we should have to use in order to transform from the algebraic expression to the trigonometric has to be given as, x is equal to a sin theta, where a corresponds to the base of the constant part. So this is what we should have to understand about. And now if we have a case whereby the variable part is subtracting the constant part, then what should be a key that will help us to transform from the algebraic expression to the trigonometric expression? If that is the case, then we should have to use this key, and which is x is equal to a sec theta, where a corresponds to the base of the constant. And likewise, if we have the constant subtracting, let's say, the variable, the key has to be given as, and by the way, the first case has to be the tan node. The first case has to be the tan. The first case has to be the tan theta. And now this case has to be given as, x is equal to, should be a sin theta. In all cases, a corresponds to the base of the constants. We should have that. So these are the keys that we use whenever we are actually transforming the expressions from the algebraic expressions to the trigonometric, to the trigonometric expressions. So in all cases, your attention has to be what is happening inside the square root. If we have the summation of the two if we have the summation of, let's say, that of the constant as well as the variable, it means in order to transform from that of the algebraic expression to the trigonometry, we should have to use this key. Likewise, if we have the case like this, whereby the variable is subtracting the constant, we should have to use this key. And likewise, if we have the variable subtracting the constant, we should have to use this key. And in addition, you just have to understand that having x is equal to a times tan theta, this is the same as having it as tan theta is equal to x over a. And now, much as the trigonometric ratios are concerned, this is opposite and this is adjacent. Then you can also have to come up with the right angled triangle corresponding to that one. And that is, let's say that is the theta that we have at C. And now the opposite to angle theta is given as x, according to the information that we have. And now the adjacent, it is given as a. So have it as that. So which means using the trigonometry, actually using Pythagoras theorem, the hypotenuse has to be given as x squared plus a squared in that way. And likewise, if we have the other case that we have it here, having x is equal to a times sec theta, this is the same as having that sec theta is equal to x over a. But what is sec theta? Sec theta is the same as 1 over cos theta, which is the same as x over a. And therefore we should have to have it as, we should have to cross multiply, or have it as cos theta, should be cos theta rather, we should have it as cos theta. X cos theta is equal to a. We should have to divide everything by x, or have it as cos theta is equal to a over x. And now according to the trigonometric ratios, this is adjacent and this is the hypotenuse. Then you can think of coming up with the right angle triangle corresponding to that one. Let's say this is the angle theta, so it means on the case of the cos theta, that is adjacent, which is a, and the hypotenuse given as x. Using the Pythagoras theorem, it means this side corresponds to have it as, should be x squared minus a squared in the radical as that. And also in the same case, if we have a case like this, we should also have to use the same principle. We should also have to use the same principle in the sense that if we have x is equal to a sin theta, that is the same as sin theta is equal to x over a. And that is this is the opposite and this is the hypotenuse. And thinking of coming up with the right angle triangle for that, we should have it as, this is the theta and that is x and that is a. Using the Pythagoras theorem, this is a side a squared minus x squared. So we should have this in mind. So how do you think we should have to integrate using the trigonometric substitution? So let us see how we can have to integrate using what they call as the trigonometric substitution, and see how best we can have to appreciate that. Now let's start with the integral of, let's say, dx of let's say the square of 4 plus x squared. So how do you think we should have this? The first thing is that u substitution for this case, it won't work. You cannot integrate this one using the u substitution, unless if we have the variable x here, that will be okay. Then you'll be able to have the u substitution technique there. But as it stands here, the u substitution, it won't work, and therefore we should have to use what they call as the trigonometric substitution. And now let's concentrate on the expression that we have inside. Now the expression that we have inside is given as 4 plus x squared. 4 is said to be the perfect square, and x squared is also said to be the perfect square. So we should have to express 4 to have the same power as that of x is having. And therefore that is the same as having it as the integral of dx of the square of 2 to the power 2 and plus x squared. That's what you can see there. Now for that case, it means a is given as 2. And now since we have the summation of the expression, since we have the summation of the constant as well as the variable, then what should be the key that you have to use if that is the case? And now if we have the summation of such cases, what it tells is that x has to be equal to a tan theta, according to the principles behind. Therefore x is equal to, what is a? That is 2 and times tan theta. We should have that. And now from there we should have the derivative of x. So what is that? We'll have it as dx is equal to 2 times, what is the derivative of tan theta? That is sec square theta. That's d theta. That is the derivative of x. And which x? Which is that? And now from there we should have to substitute this into the original integrand. That will be given as the integral of, what is dx? We should have to substitute that on. That will be given as 2 sec square theta d theta divided by square of 4 plus what is x? We should have to have that as that. Therefore, have it as, 2 tan theta to the power 2. And since the x is a square t, we'll have that as that. And now from that point, what it entails is that we have to simplify. We'll have it as the integral of 2 sec square theta d theta divided by, and thus we should have it as the square root of 4 plus 4 tan square theta, like that. And now we should have to factor out 4 since those are the right terms. Actually, since that is the common, and since that's the common factor, then we should have that as, the integral of 2 sec square theta d theta, and that's divided by the square root of 4 times 1 plus tan square theta. We'll have it as that. And now we should have to understand that if we have, let's say, the square root of AB, if we have the square root of A times B, this is the same as square root of A times the square root of B. Thus, according to the nth, should be according to the laws of indices, or should be the nth root properties. We should have that on. So if that is the case, then we have the integral of 2 sec square theta d theta divided by, a square root of, it should be square root of 4 times the square root of, that is 1 plus tan square theta. We should have it as that. And therefore what it entails is that we should have it as the integral of 2 sec square theta d theta divided by 2 times the square root of 1 plus tan square theta. Now these two cancel. We'll have it as the integral of sec square theta d theta divided by, what is the 1 plus tan square theta? Using what we call as, Pythagorean trigonometric identity, that is the same as having it as the square root of sec square theta. So what is the square root of sec square theta? That is the same as having it as, sec theta. Therefore, we should have it as something about the integral of sec square theta d theta over sec theta, which is the same as the integral of sec theta d theta. So what do you think is the integral of sec theta? So according to the integration table, the integral of sec theta is given as, so it is given as that of the natural log of, and that is sec theta plus the tan theta and plus c. That is what we call as the integral of a sec theta. So which means even if we have the integral of sec x, that is the same as, a sec x plus tan x. We should have that. But as you can see, we have managed to integrate the expression. But now the expression has been integrated in form of should be theta. But now our original expression wasn't in that of a theta. It was in form of x. And therefore, we should come back to where we transformed it from theta to should be from x to theta. And which is this? And now from this point, what we need to understand is that having 2 should be x equal to 2 tan theta. That is the same as tan theta is equal to x over 2. That is the same as that. You should have to understand that and understand. So which means that tan theta is the same as x over 2. That will be placed there. And what is this sec theta? A sec theta, and by the way, let me have the right angle triangle corresponding to the information. Let's say this is the theta, so which means on the tan theta, this is the opposite and this is the adjacent. So which means this is the x and this is the 2. Using the Pythagoras theorem, this is now being given as x squared plus a squared, that is in the square root. So what is sec theta? Sec theta corresponds to have it as 1 over cos theta. But what is cos theta? Cos theta corresponds to have it as, cos theta corresponds to have it as, should be adjacent hypotenuse, which is the same as 2 divided by the square root of x squared plus should be what is that? This is, by the way, this is 4 and this is 4. So we should have it as that and as that. And that is a 4. So which means now what you have is sec theta is the same as, having 1 divided by 2 over the square root of x squared plus 4, of which this is the same as having it as the square root of x squared plus 4 divided by 2. That is the value of the sec theta. So let's go back and substitute for this. Now the final solution will be given as a ln. What is sec theta? Sec theta is the same as that. So have to substitute it as the square root of x squared plus 4 and divide by 2 and plus what is tan theta? Tan theta is the same as that one, so have it as x over 2 and plus c. So that's how we should have to integrate using what they call as the trigonometric substitution of that manner. Right, so in the same case we have the integral of, let's say, should be somewhere about let's say dx over the square root of x squared, let's say plus 25 dx. So how do you think we should have to integrate this one? Principle remains the same. Should be use substitution one tweak for this case. We should have to use what they call as the trigonometric substitution, and we have the summation of that of a constant as well as the variable. So looking at it clearly, this is the same as having it as the integral of dx over the square root of x squared plus 5 to the power 2, and therefore a is given as 5. So what should be actually a key to transform from the algebraic expression to the trig, or have it as x is equal to actually 5 tan theta, and therefore what is dx? So have it as 5 sec square theta, sec square theta d theta, and therefore we should have to substitute that into the original expression. That will be given as the integral. What is dx? That is 5 sec square theta, should be sec square theta d theta, and divide by we'll have the square root of x squared. And what is x? X corresponds to have it as, which is that? So have it as 25 tan square theta and plus also 25. We'll have it as that. Using the same way we have done it before, what it tells is that we'll have it as the integral of 5, integral 5 sec square theta d theta, and that's divided by 5 times that of sec square theta. If we adduce the same principle, have it as the integral of, and this 5 will cancel. What you can have is, should be, have it as actually integral of sec theta d theta, of which in the same case we should have it as ln of sec theta and plus tan theta. We'll have it as that and plus c, and we should take it back using this key. That's a substitution key rather we can have to equate as that. And in the sense that if we have x is equal to 5 tan theta, that is the same as tan theta being the same as x over 5, and that is opposite, and this is the adjacent. So we should think of coming up with the right angle triangle corresponding to that one. Let's say this is the angle theta, and that is should be x, and this is 5. So using the actually using Pythagoras theorem, that is the same as having this x squared plus should be now 25. So what is it? Tan theta? Tan theta is the same as x over 5. That is okay. But now we are remaining with sec theta. What is sec theta? You know, for that case, sec theta corresponds to have it as, try to have it in the same way we have done it before, and appreciate that. Okay, now what if we have this kind of a case? Now let's say we have the case given us, let's say the integral of, and should be, let's say, dx of the square of, should be, let's say, 9 minus x squared. So how do you think we should have to integrate this expression? So according to the principles behind, having 3, it should be in 9, that corresponds to have it as 3 to the power 2. We should have that. And therefore, a has to be given as 3. And as you can see, we have the difference whereby a constant is subtracting the variable. And what should be the translation key? We should have to understand that we'll have it as x is equal to 3 sin theta. That's whenever we have that kind of a case. And what is dx? Dx corresponds to have it as 3 cos theta. That is the derivative of sine. Then we should have to substitute it back into the actually expression. We'll have it as the integral. Should be the integral of what is dx? That is 3 cos theta d theta divided by, should be the square of, and that's 9 minus, what is x? X is given as 3 sin theta. That is the same as 9 sine square theta. We'll have it as that. Using the Pythagorean trigonometric identity, should be Pythagorean trigonometric identity, we have it as the integral of 3 cos theta d theta. That is the same as having it as, should be the square of 9 times the square of 1 minus sin square theta. Of course, using the Pythagorean trigonometric identity, that is the same as cos square theta. So what is the square of cos square theta? That is the same as cos theta. Therefore, have it as the integral of 3 cos theta d theta of, and now this is 3 and times cos theta. We should have to cancel these, so have it as that, and therefore have it as the integral of d theta. So what is the integral of 1 d theta? That is the same as, theta plus c. That is the integration. But now, as you can see, we have the, the expression in form of a theta, not as x. So we should have to take it apart. So what is the value of theta? We should have to come back to this. So always don't forget about this, actually, transformation key. It is always important, you should have to keep in mind. So we should have to understand that having x is equal to 3 sin theta, that is the same as sin theta is equal to x over 3. And mind you, this theta is the same as this theta. And therefore, a theta is equal to sine inverse of x over 3. So that is the value of the theta. Therefore, we should have the solution being given as the sine inverse of x over 3 in plus c. That is the solution. And now what if we have, let's say, a case like this, and see how we can have to appreciate that one. What if, let's say, a case has been given as this? Let's say if we have the integral of x squared dx, let's say divided by square of somewhere about, let's say, 9 minus, let me have something different. Let's say it should be 16 minus x squared. So how do you think we should have to integrate this expression? As you can see, use substitution 1 to 8. So principle remains the same. We should have to use the trigonometric substitution. So having 16 is the same as 4 to the power 2. And therefore a is given as 4. We should have that. And now since we have the difference whereby the constant is subtracting the variable, it means we should have it as x is equal to 4 times sin theta. So what is dx? We'll have it as 4 cos theta d theta. We should also do the same. Now we should have to substitute. We have x there, we should have to substitute with its value. Thus we should have it as 16 sin square x. So have the integral of 16 sin square theta should be like that. Sin square theta rather, that is sin x square, should be that x square. And what is dx? A dx is given as, now we should have it as 4 cos theta d theta, and divide by, we should have it as 16 minus, what is x? We should also have it in the same way. We'll have it as 16 sin square theta, like that. That is the same as the integral of, that is 16 sin square theta, of course, times 4 cos theta d theta divided by, of course we'll have it as 4 times cos theta at the end of the day, if we do everything in the right order. Now this 4 and this 4 cancel, and this will cancel. What you can have is something, let me keep this on safe somewhere here. And now what I'll have, what we're going to have is the integral of, now we have it as 16 sin square theta d theta. So there is no direct integration that can be done on the sin square theta, but now we should have to apply the trigonometric identity. That you should have to understand that having sin square theta, that is the same as, now we should have to take 16 out, integral of, that is the same as having that one as 1 minus cos 2 theta over 2, and that's of d theta. So that's the identity we should have to keep in mind, of which this 2 and this will cancel, have it as 8. Therefore have it as 8 integral of 1 minus cos 2 theta d theta. Mind you, there's no direct integral that we can have to operate for that one, so therefore we should have to express that one as this. And now from there we should have to integrate. That will be okay. And thus we should have it as 8 outside times, what is the integral of 2? Actually 1, that is theta. And what is the integral of cos 2 theta? Now for that case, we use what we call as the chain rule of integration. That will be given as the integral of the outer function. That will be given as sin 2 theta, and divide by the derivative of the inner function. So what is that? We'll have it as theta. That will be given as 2, and plus c. And mind you, having sin 2 theta, that is the same as having it as 8 theta minus sin should be 2 times sin theta cos theta. That is double angle identity for the trigonometric functions, and plus c here. And this will cancel. That will be given as, now something about, you have to, that is the same as the integral, but actually we have already done the integration, therefore just have to simplify it further. That is the same as, now we have it as, should be 8 theta minus sin theta cos theta and plus c. But now we should have to express the solution in form of x not as theta. Therefore we should have to use this, and thus we should have to understand that having x is equal to 4 sin theta, that is the same as sin theta is equal to x over 4, and therefore we should also have it in the same way, in the sense that we should have something about, this is opposite and this is hypotenuse. A typical right angle triangle will be given as this. This is x and this is 4. Using the Pythagoras theorem, that is the same as having it as the square of, it should be 16 minus x squared. That will be that. And now let's start. What is the theta? Theta corresponds to have it in the same way. Theta is equal to a sine inverse of x over 4. That will be given as theta. And what is sin theta? Sin theta corresponds to have it as the same way. A sin theta is the same as x over 4. What is cos theta? We should take it here. A cos corresponds to have it as adjacent hypotenuse. So cos theta will be given as square root of 16 minus x squared divided by 4. Then we have to substitute this in the solution. Then we'll have it as 8. What is theta? That's the sine inverse of x over 4, of course. And the minus, what is this sine theta? That is x over 4 n times. So what is cos theta? That is the square root of 16 minus x squared divided by 4. Of course, we can have to multiply this. That will be given as 16. And by the way, plus c here. Therefore, 8 sine theta should be a sine inverse of x over 4. And thus we should have it as x times the square root of 16 minus x squared divided by 16 and plus c at the end. We should have that. So apologies, I do actually experience some sort of stammer, so just have to understand. Now, what if, let's say, this is the kind of a case? Let's consider the integral of, let's say, somewhere about, we have it as dx and divided by, let's say, the square root of, should be 25x squared, and say minus, let's say, 4. So how do you think we should have to integrate this kind of expression, if that is the case? So our focus has to be what we have inside the square root. So we have the variable subtracting the constant, of which having 25x squared minus 4, that is the same as 5x to the power 2 overall minus 2 to the power 2, and therefore a is given as 2. And now, since we have the variable subtracting the constant, it means the integration key, actually a transformation key, has to be associated with the sec theta. And therefore x, now since we have the product of, in other words, since x is having the coefficient as 5, then we'll have it as 5x is equal to 2 sec theta. And this happens because x is having the coefficient as 5. We should also have to put all of that on there. And therefore it means x is given as 2 over 5 sec theta. Then what is the derivative of x? We'll have it as 2 over 5 sec theta tan theta d theta. We'll have it as that. So we should have to understand that and understand. Then from that point, we should have to substitute. We should have to substitute in the sense that we just have to keep. Rather, should have to keep this. That will be important at some point. But principle means the same. We should have to substitute. We have it as the integral. What is dx? That is 2 over 5 sec theta tan theta d theta divided by the square root of 25. And what is x? X corresponds to have it as that, and therefore we have it as, it should be 4 over 25, a sec square theta and minus 4, as you can see here upon substituting that. And this will cancel. What we only have is something about, we'll have it as the integral of 2 over 5 sec theta tan theta d theta and divide by, we have the square root of 4 sec theta minus 4. And now from there we have to understand that now the situation will go like this. Now the situation can go like this. We'll have it as the integral of 2 over 5 sec theta tan theta d theta and divide by, that is the same as 2 times that of the tan square theta, according to the Pythagorean trigonometric identity, if we simplified further at that point. And by the way, we have factored out 4, and we are remaining with sec square theta minus 1, which is the same as tan square theta. And now from there, what you have is something about, should be the square root of 2 over 5 divided by 2, of course, that's like how you can have it, and sec theta tan theta d theta over tan theta. This and this will cancel. We'll only have it as, should be 2 over 10 integral of sec theta d theta. What is sec theta? Integral, that is the same as 2 over, should be 10, by the way, which is the same as 1 over 5. So 1 over 5, a ln of the absolute value of sec theta plus tan theta and plus c at the end. So we should come back and have what is a sec theta and what is tan theta then. So we should have to use the transformation key. So what is that? We should hold it as we should have to hold it as, having x, that is the same as, x is equal to 2 over 5 sec theta, that is the same as having it as 5x is equal to sec theta, of which sec theta should be 1/2 sec theta as the subject, of which sec theta, that is the same as having it as 5x over, should be 2, of course. And what is sec theta? Sec theta, there is no direct relationship between the sec theta and the right angle triangle. Therefore, we should have 1 over cos theta, that which is equal to 5x over 2. And now from there, we should have it as 2 is equal to 5x cos theta. We should have it as that. And now we should have to take it as, that is cos theta is equal to 2 over 5x. That should be given as that. And now we have, this is adjacent and this is the hypotenuse. And we should have the typical right angle triangle. What it does is that if this is the angle theta, and that is 2, and this is the square of, should be, that is 5x, and therefore it means this side corresponds to have it as the square of 25x squared, and thus minus 4. That should be given as that using Pythagoras theorem. Now, what is sec theta? A sec theta, we already talked about it as, a sec theta has to be given as, should be 5x over 2, as we already had it before. We'll put it here. But what is remaining is about the tan theta. What is tan theta? We should have to use this triangle. Try to complete that one at your own time. That's just to see how you can have it. At your own time, try to integrate the following cases. The integral of, should be x over the square root of, should be 9 minus x squared dx. Try that one. And also the integral of, let's say, 8 dw over, let's say, w squared times the square root of 4 minus, let's say, w squared. Try have that one as well. And what if, let's say, you have a case like this, and see, let's say the integral of 0 to, let's say, the square root of 3 over 2. You know, this is a definite integral, so we should have that one. And of 4x squared dx, and divide by the, should be the square root of, that has to be 1 minus x squared. Don't try that one. You also have the integral of, there should be somewhere about, you know, we should also have the case like this. Let's say 5 dx divided by the square root of, let's say, 16 square, somewhere about, and let's say minus 4. Try to have that one. Should it be 16? No, we should have, should be 25. We should have it as 25, rather, but it should be the same 16. You should have to try that one. And also try to evaluate this and see how we can have, let's say, the integral of dx of, let's say, x squared times the square root of x squared and plus 1. Try to have this one as well and see how we can have it. And also we should have to try this as well. What if, let's say, we have the integral of 2 dx divided by, let's say, x cubed times the integral should be x squared minus 1. That's like that. And preset that one as well. And now what if, let's say, a case like this has been given? Let's say if we have a case like this. What if we have, let's say, an integral of 3 dx of, let's say, the square root of 1 plus 9x. So try to have that one. So that's the basic idea behind what they call it as the trigonometric substitution. But now, what if in some cases we have a case like this? But now, I want to see the responses in the comment section below, if at all you have managed that one. Let's say integral of, you know, dx of square root of, should be x squared minus 6. What if this is not that of the perfect square, of which that is the same as having it as, you know, having 6 is the same as the square root of 6 to the power 2. So which means the base of 6 is the same as the square root of x, actually a square root of 6. So which means a is given as the square root of 6. Then take it from there. And what if, let's say, I have the integral of, should be dx of, let's say, a square root of, should be somewhere about this. Should be, let's say, 3x squared minus, let's say, 7. So how do you think you can have this one? Using the same principle. But now for this case, 3 is not a perfect square. Therefore, we should have it as a square root of 3x to the power 2. It is the same as that. And also having 7 is the same as square root of 7 to the power 2. So therefore, it means, you know, take it from there. We should have to see your ability there. So that's how we start to understand about, you know, trigonometric substitution in the basic ideas behind. Thank you.